Question 11 says, evaluate the expression 2,000 times 1.08 to the 10th power on your calculator. It should match the last row in your table. 2,000 times 1.08 to the 10th power. Is that the same thing that we had in the table? 4318 is what I wrote. So yeah, that's basically the same amount of money. And that's because this is the same as taking 2,000 times 1.08 times 1.08 times 1.08 10 times. You're multiplying it repeatedly because every year we increase by 8%. So if I were to type this out 10 times, and I'll spare you, then we would have the same thing that we had up here, which is 1.08 to the 10th power. Right now it looks like I only have about 5 repetitions there. But yeah, that's a sneaky shortcut method to go to the end of 10 years without creating a whole table. In fact, what we'll do is, if we want to predict the balance on the account in 20 years, we'll just put in 1.08 exponent 20 to get that amount. And that's your $2,000 initial investment grew to $9,322 at the end of 20 years. 8% every year. Compound interest grows pretty dramatically in the long run. It grows slowly at first and then it starts to speed up. In the next table, I wanted to compare linear growth and exponential growth. So the linear account, well, they both start with $2,000, and then the linear account, the owner deposits $250 every year. The other account grows exponentially because the account earns 9% interest every year. Do you think you know how to complete this table on your own? This one's going to be plus 250, plus 250, plus 250. How are you going to make this account earn 9% interest every year? Hopefully you know that you need to multiply by 1.09, 1.09, 1.09 in order to get yourself to the end of this table. And we're going to go all the way to 15 years to see what happens in both of these accounts.